Hello everyone, and welcome to A Bricklayer's Guide to the Galaxy. For 11 years I worked as the founder, director and the lead astronomer at the Fildes observatory. One object stood out more than any other amongst the people who visited us at the observatory, and that without doubt was the Andromeda Galaxy. So I've decided to put together this short video to give you some information about this amazing object. So sit back and relax, and I hope you enjoy a brief history of the Andromeda Galaxy. Edwin Hubble spent several months in 1923 scanning the Andromeda Galaxy with the 100-inch Hooker telescope at Mount Wilson, California. And on the night of October the 5th in 1923, Edwin Hubble began an observing session that lasted until the early hours of the next morning. And what he noticed was a special type of star that seemingly changed its brightness over a specific period of time. What Edwin Hubble had actually discovered was a type of star that had been categorized earlier by a scientist known as Henrietta Swan-Leavitt, and that type of star was known as a Cepheid variable. Edwin Hubble had actually discovered a way to measure distance to the Andromeda Galaxy. If you know how bright an object is, like a star in this case, you can measure its distance. So if you look on this image, what we can see in the bottom right hand corner is one of Edwin Hubble's actual plates of that night's observing run. Now if you look into the top right hand corner, you can see the letter N, and that's been crossed out. Now the N is representative of novae, a certain type of exploding star, a star that's getting brighter over a period of time. But if you look above the N that's been crossed out, you will see where it says var. Now that var stands for variable, and it's got two lines highlighting the position of var 1. This is the Cepheid variable star. That's the star that Edwin Hubble found inside the Andromeda Galaxy that he used to measure distance to the galaxy. All of the little dots we can see on the graph are telling us that as the distance increases in megaparsecs, so does the recessional velocity of the galaxies he observed. Or this led to the realization by Hubble that the universe had to be expanding. So this recessional velocities of galaxies that increases over distance was categorized with the equation, of course, V equals h naught d. Velocities equal the Hubble constant over distance. The Hubble constant is now around about 68 kilometers per megaparsec of space, which essentially means if you have two galaxies around about 4 million light years apart, their separation will increase at a rate of 68 kilometers per second. And this is what astronomers and cosmologists will use to measure the expansion of the universe. So with all of this knowledge, we can safely establish that Edwin Hubble was absolutely instrumental in understanding how the Andromeda Galaxy played such an important part in the realization that the universe had to be expanding. So let's move on now then and look at some wide field images taken of the Andromeda Galaxy in the sky. In this image that I took about 2 or 3 years ago now, I think, I took it with a Canon DSLR camera, and in the upper right we can clearly see the Andromeda Galaxy. Now off the lower left we see the Triangulum Galaxy. So when you look at the stars in this image, remember that they're all in the foreground. These two galaxies, Andromeda and Triangulum, lie way, way, way beyond that. The Andromeda Galaxy is around about 2.3 million light years away, meaning that light travelling at the speed of light takes 2.3 million years to get to us. Now, because of this amazing fact of physics, what this allows astronomers to do is we can actually look back in the very, very distant universe and see what the universe was like at these very, very early times. What I decided to do was I wanted to put a camera on the back of a telescope and get a high resolution image of the Andromeda Galaxy, which is the one we see here now. And now, for the first time, we start to see structure in the galaxy. Furthermore, there seems to be a fuzzy little patch of light beneath the galaxy. This is Messier 110, which is a small spiral galaxy. It's a dwarf galaxy that's actually orbiting around the main Andromeda Galaxy. And there's also another one further up to the left at around about 11 o'clock, which looks like a really bright star. This is actually another galaxy known as Messier 32, which again is a satellite galaxy of Andromeda that's orbiting around it. You can also try to notice the differentiation of the colour in the galaxy. As we move towards the centre of the galaxy, we see a more yellower light.
As we move towards the edges of the spiral arms of the galaxy, we see a red or bluey coloured light. This is due to different types of populations of stars that live inside of this galaxy. And the dust lanes that you can you see the dust lanes? These are made up mostly of the so-called polycyclic aromatic hydrocarbons, which are leftovers from big stars exploding. And as the big stars explode, this dust and this gas collects in the spiral arms of this beautiful galaxy, only to go on in later times and build new stars. We've discovered that the Andromeda Galaxy and the Milky Way are actually going to merge together. So in an expanding universe, you may wonder, how is it that two galaxies can actually be coming together? There's another player in the universe as well, known as gravity, which molds and shapes the universe, of course. So this uniform expansion to the universe almost through this effect of vacuum energy or the dark energy doesn't really have an effect on you, or it doesn't have an effect on the instruments we use to measure the expansion of the universe. Because if it did, well, everything would be uniformly expanding, so we could never measure the uniform expansion. So there has to be something that's going on, and that thing is actually gravity, albeit it's the weakest of the four fundamental forces. It's actually strong enough to overwhelm the effect of dark energy. So the galaxies we can see are being attracted to one another. And eventually, as time progresses, what starts to happen is the two galaxies, the main players, the Milky Way and Andromeda, get so much closer and closer and closer that their spiral arms actually start to merge. Now at this point, let's leave the physics and the astronomy behind a little bit. Now what I want you to do is I want you to try and imagine what this will look like. Could you imagine for just a second standing out in the nighttime sky and looking up and just seeing this huge galaxy start to merge with our Milky Way? Artistic impressions think it might look a little bit like that. I mean, wow, can you imagine what this will be like for astronomy? If we can stay alive long enough, the sights we will see will be nothing short of spectacular as the two giant galaxies start to merge. And the merger continues and continues for another 2 or 3 billion years. And we can see the Triangulum galaxy flies away and flies past. And then until the two galaxies have really truly merged, it's at this point that the two nucleuses of the galaxies knit together and merge. And then we will see what will really happen inside of a galactic merger. Many people think that when the two galaxies collide, there's going to be stars crashing into one another and planets smashing into one another and these huge pile-ups. Well, the reality isn't that at all, because the distances in between the stars is vast. So what causes this huge mess, like we can see on the screen at the moment, when all this light and all of this dust and all of this gas, what's going on if all the stars are missing each other and not flying by one another? Well, what's happening is the dust and the gas and the gravitational influence of all of that stuff is being mixed together. And whilst collisions will be very, very rare, what will collide and merge together is the dust and the gas. Hydrogen is the lightest and most abundant element in the universe, formed shortly after the Big Bang itself. And because hydrogen is ubiquitous throughout the universe, it plays a key role in this merger. If you look at the bright red regions and the pink regions, these are regions of hydrogen gas that are collapsing in on themselves under the influence of this merger. And as this dust and gas collapses, it builds new, hot, big, young blue stars. And as these blue stars shine out their ultraviolet light across the universe, this light, photons and UV, will interact with hydrogen atoms, and this interaction excites the hydrogen atom, and as its electron returns back down to its ground state, it emits light at a set wavelength of 656 nanometers, which is known as the H-alpha light. And this light energy fluoresces this pinky red colour. And if you're used to seeing, for example, the Orion Nebula, you will see the same pinky red. And this pinky red is a telltale sign of stars forming in big clouds of hydrogen gas that's releasing all this light. So rather than, seemingly, a huge collision that destroys stars and planets, we see the birth of new stars in galactic mergers. We see new solar systems forming before our eyes when our galaxies merge together. So all of these new stars and new solar systems will be born in this collision. Imagine if life exists during this time. Imagine what their nighttime skies will look like when they look out and see that. I think then everybody will be an amateur astronomer. Nobody will want to watch Coronation Street or watch any TV whatsoever, right? I mean, everybody's going to be wanting to go outside and look at this actual merger. But this, of course, is in many billions of years, at which point humans will have evolved into something else, no doubt. That's if we're still around at all. What will happen eventually is all this dust and gas gets used up and the new stars form. And when all the dust and gas is gone and all those stars start to die out, then what will happen? This new combined group of stars, known as Andromeda, I believe, will turn into what's now commonly known as these big giant elliptical galaxies. Elliptical galaxies are what we classify in astronomy as being red and dead. They don't contain any blue stars at all, mostly. They're just full of these big old red stars. And eventually, we'll go from having that beautiful sky full of pink light and star-forming regions and dust and gas and mergers and collisions to a white, reddy-coloured blob of light in the sky that doesn't have many features at all, other than no spiral arms, no dust, no real rotation. But something extraordinary will have happened during the merger of our two galaxies. When we look out into the universe, we found many examples of galaxies colliding and merging together, and the resulting merger produces normally these huge big elliptical galaxies. So we can look out into our local group of galaxies, which is not that far out, maybe 1 to 2 to 300 million light years, and we find a beautiful big galaxy known as Messier 87. I mean, look at this. This galaxy is absolutely enormous, and it's shooting out this blue jet. So what could that be? In 2019, the Event Horizon Telescope team imaged for the first time a black hole. The black hole in the Milky Way galaxy we believed to be about 4.26 million times more massive than our Sun. And it was an amazing discovery, a feat of engineering and scientific ingenuity that gave us this real breakthrough. In this movie that you're looking at now, what you will see, this is the real footage taken by the VLT telescope, the Atacama Desert in Chile. And what's actually happening is every single one of these spots of light is a star right at the very heart of the Milky Way galaxy. Using amazing technology and resources, the team were able to see through all of the dust and the gas and the fields of stars that lie at the centre of the galaxy, which would normally obscure this view. If you look, there are some stars that are moving really very quickly. And there's one in particular called the S2 star that is moving so fast when it approaches an object we cannot see. Now the idea is this. In Newtonian physics, we can use Newton's laws that tell us how an object will move. Well, if you think about Newton's first law, that an object will remain at rest or continue in uniform motion unless acted upon by an outside influence. Well, if there's no gravity in the universe, but let's pretend we still had stars, then what the stars would do is they'd just carry on moving in straight lines. Something has to make the stars change the trajectory, and that something is gravity. And what we found using Einstein's general theory of relativity, he gave us a really radically different way to think about gravity. And that way is this, is that gravity in its essence isn't a force at all. What gravity actually is the geometry of space. That mass tells space how to curve, and space tells mass how to move. So in the case of Newtonian physics, it doesn't work with gravity consistent in general relativity on the universe. So these stars in this image aren't following straight lines because there's something in there that emits no light, that's curving space so heavily and warping it that as the stars move through this warped space, they want to carry on in a straight line, but they can't. So all you have to do as a scientist then is work out the trajectories of these stars, how fast they're moving, and then you can work out the mass the object has to be to curve and warp space in such a way that the stars move in these strange trajectories. And this is how the science team worked out a supermassive black hole is responsible for these stars moving the way they did. So using this type of technology, the team were able to look at an ultraluminous X-ray source, the centre of the Andromeda Galaxy. In this image here, we can see the region just like we did in our Milky Way, where a supermassive black hole lurks at the centre of the Andromeda Galaxy. And it is these two galaxies that will merge together and give us the huge black hole that we think will exist at the centre of this galaxy in many billions of years to come. So I hope you've enjoyed all of this interesting scientific information, but before we leave and before we end, I want to actually show you and talk you through one of the most amazing videos I think I've ever seen on the web to date. This video essentially is going to start off looking at the Andromeda Galaxy in the sky, and then what we do using stunning resolution through the Hubble Space Telescope, peer for the first time into the heart of a galaxy. So sit back and relax and get ready to go on the ride of a lifetime. Well, this is what the Andromeda Galaxy would look like. And if we get up nice and close and personal with Tony Hallis's and the Hubble Space Telescope team's image of Andromeda, we see it in all its beauty. So the red box outlines a section what we're going to have a look at. And this is a journey, folks, as I said, like you've probably never had before. And it's about resolution. Look at how many pixels are in this image. 1.5 billion pixel image of the Andromeda Galaxy is going to give us a startling glimpse of the sheer scale of this amazing object. And as we get further and further in, what we start to see is structure. Firstly, notice there are largest field stars that have been caught in between the Milky Way and this galaxy that we've imaged. And in this annotated cutout, we can see what we're looking at. We can see there are Milky Way stars that have been just quite literally caught in the foreground. And of course, there are the dust lanes, and there are even clusters of stars. They are the stellar clusters, things like globular clusters, for example, and even star-forming regions. But what I want to really draw your attention to is, of course, these background spiral galaxies. Can you see them? Up to the right at around 1 p.m, you see two background spiral galaxies. So folks, what this is the Hubble Space Telescope has taken this amazing image of the galaxy, but it peers through the galaxy and it can actually see two galaxies that lay way, way beyond that. Many hundreds of millions of light years, we pick up these two background spiral galaxies. Isn't that just absolutely amazing? We also see some dust lanes, so all the dust and gas that's necessary for building new stars, as we looked at earlier, is present in this galaxy in abundance. So as we get closer and closer in, we're able to start to resolve more and more detail and more stars on smaller and smaller scales. It's this realization that hooks me into astronomy, and this is why I'm not a brickie anymore. So what I mean is, take a good look at every single point of light on that image, because every single point of light is a sun just like our own. Some will be bigger and some will be smaller. Some will be hotter, some will be cooler. But essentially they're stars. And our sun is a star also. What we now realise through modern research is that over 95% of these stars have planetary systems, have solar systems. That's just spine-tingling. So think for a second of those planets. Think of the morphology of them, the geography, the geology, and think even maybe about the life on some of these worlds. There is enough science in the Andromeda Galaxy to keep every school kid interested and hooked into what really matters from now until the end of time itself. I hope, whilst you're watching this video, you'll sit your kids down and let them see the grand enormity of what we're actually part of and how amazing it is to be part of this journey and how wonderful it is to be living at a time when we can utilise our research astronomers and our engineers to produce amazing footage like this so we can get a better idea of our place in the universe. So as we end our journey into the Andromeda Galaxy and we start to zoom out, I don't think many of us will ever forget that journey, probably the best one you'll ever take. And as it zooms back out into the sky and we see the Andromeda Galaxy hidden amongst the star fields of our Milky Way, amongst the stars and constellations where it will remain for the next 4 billion years until the merger begins.
Well, thanks for watching, folks. I hope you really enjoyed that and you found it informative, learning all about the Andromeda Galaxy. But of course, our universe is vast and awe-inspiring as ever. So there's many objects to look at and lots of facts to learn, and hopefully we can all do that together. So at the end of this video now, you're going to see all my social media links pop up, so hopefully you're going to follow me. But more importantly, I hope you leave some links at the bottom of the page of your own that we can all share, and ask some questions. What does the Andromeda Galaxy mean to you? How important is astronomy for you in your life? And do you think maybe that the nighttime sky and our awareness about a universe around us all could change your life like it did for me? If you've got any experiences of that, I'd love to hear about it all. But until next time, thanks for tuning in to A Bricklayer's Guide to the Galaxy.